In this video, we're going to talk about solving using the square root method and kind of the simplifying of a radical idea. So here's a little just short blurb from Algebra 1. We're not going to be so worried about this index piece here because we're going to be just looking solely at an index of 2. And when our index value is 2, we just don't have a number there. But you need to know the difference between a radical and a radicand. Radical is the symbol, radicand is the thing underneath the symbol. When we are taking square root, it's just the inverse of squaring. It's what factor multiplied by itself will equal the given square. So if I gave you the square root of 36, the answer is just 6. I am giving you the answer of a positive square root of 36. 6 times 6 equals 36. That's how I get my answer. Here I'm giving you a negative square root of 36. Well, the square root of 36 is still 6, but now my answer has to be the negative. If I give you a plus or minus symbol, I'm going to have a plus or minus symbol. This means plus 6 or minus 6. And where this matters is when we take the square root. When it's not there and we put it there, you are going to get 2 answers every single time. You will need to be able to simplify your radicals. In order to simplify your radicals, there can be no perfect square factor underneath the radical in the radicand. There are no fractions in the radicand, and there's no radical in the denominator, the bottom part of a fraction. When you're adding, subtracting, multiplying, dividing, there are different rules that take place. If you are multiplying things together, the stuff in the radicand goes with the other stuff in the radicand. The stuff outside goes with the stuff outside. So we'll do a couple of these really quick. Square root of 500 is going to be a very short thing. You could write this as a square root of 5 times 100, which is the square root of 5 times the square root of 100. Those are exponent properties, radical properties. Square root of 5 is square root of 5, but the square root of 10 is, or square root of 100 is 10. My final answer I would write as 10 times the square root of 5 like this, so that I don't accidentally think that that's square root of 50 by mistake, or accidentally put the radical symbol over the 10 for the wrong reason, just by accident. It is not a plus or minus because we are given the positive square root to begin with. In number 32, there's a couple of different ways you could do this. I'm going to start with taking the stuff that's underneath the radical and multiply them together, but I'm not actually going to complete that multiplication. 12 is 2 times 6. And what I've done is found a pair of 6s to match with my index that's hiding as a 2. And this is going to give me 3 times a 6 that breaks out with a 2 that got left behind. Okay, if you find a perfect square number underneath the radical, that means that you have a factor times itself underneath the radical. I did not need to multiply this out to get 72. 2 times 36 is 72. Square root of 36 is 6. I didn't need to multiply that all out to do this. My final answer is going to be 18 square root of 2 because I still have to multiply that 3 times 6. The other way I could have done this is change 3 times the square root of 12 to 3 times square root of 4 times 3 times square root of 6 this way. The square root of 4 is 2, which is kind of nice. So I would have had 3 times 2 times square root of 3 times square root of 6, which gives me 6 times the square root of 18. But then I need to remember that this is 9 times 2, and it just becomes a much longer process to get to the exact same thing. The reason I show that is because depending on what you see as factors, some things are going to jump out as more obvious. For myself, I know 6 is a factor of 12, so once I saw this 6, I knew I was going to go with that route. If I didn't recognize that, or if the numbers were bigger, I would go this other route to get me to smaller numbers that I'm more familiar with. For number 33, if it's written as a fraction, you can rewrite it as a fraction of 2 different radicals. This becomes 5 over the square root of 3 very quickly because the square root of 25 is 5. Again, we're given the positive radical, so I don't need any plus or minus. But now, I can't have a radical on the bottom, so I multiply top and bottom by the exact same thing. And the thing that I pick is the square root that's on the bottom, specifically so that when I take square root of 3 times square root of 3, I just get 3 with no more radical on the bottom. In this case, that's my final answer. Depending on what happens in the problem, if you can simplify that fraction, that 5/3, you would. So if that had been a 6 square root of 3 over 3, I would simplify this down. But since it's just a 5, I don't have to worry about it. For number 34 here, I'm going to start, and this is something that you don't necessarily always need to write down. I oftentimes don't write it down. I just kind of think about it. I just split it up. So I have different radicals. Now, I'm not really changing anything here. I'm rewriting it in a different way, but I still have everything that was on the top, everything that was on the bottom is on the bottom. The reason I did that is so that I can treat this as these two fractions instead. Because I know that 2/8 is 1/4. I know that 15/5 is 3. Well, the square root of 1/4 is the square root of 1 over the square root of 4. Square root of 1 is 1. Square root of 4 is 2. Okay, that's a problem that takes me longer to write than to actually do. There was nothing stopping me up at this point from saying the square root of 30 divided by the square root of 40. Okay, nothing stopping me. I would have simplified and said, well, that's the square root of 3/4. Well, then I would have to split it and square root of 3 over square root of 4 and still simplify. But if you can recognize certain factor pairings, it makes your life go a little bit easier and problems go a little bit faster. Okay, so that's a quick rundown of simplifying radicals. In the next video, we'll actually get to solve by square roots. Have a great day, everybody.